It's going to be less politically correct. You know it's going to be fat. Where would the vertex be? It's really easy. What's B?
0.
0. So the vertex is at 0. And when you plug in 0, you get 0. I like it. So it hasn't been moved up or down. There's no plus or minus in it. It hasn't been moved up or down. It hasn't been moved left or right because there's nothing in with the x. So it's still at 0, 0. It's just been squished down. So again, so graphing this wouldn't be that difficult. I might go out to 2, 4, and -2, -4, -2, 4. My scale is horrible, but it will. And then I take 1/10. So what's 1/10 of 4? It's a little less than a half, right? I mean, what's 1/10 of 4? 4/10. You guys kind of with me? 0.4. It's a little less than a half. So here, instead of going to 4, it's going to go to a little less than a half. Here it's going to go to a little less than a half. So that's going to be the new graph. Pushed it down. You can only rise 1/10 as quick. All right. Okay, cool. I like it. Maybe. And then it says, what's f of 5? Is that what it was? Yeah, just plug it in. 1 over 10 times 5 squared. It's nothing major. Just ask me what's f of 5.
But my problem with the 5 is, am I starting with 5? Because I know my vertex is already 0, 0.
No, so you're trying to bring other things in. This function happens to be parabolic when you graph. So there's a vertex for it, right? All right. This is strictly, it doesn't even matter for this question. This question doesn't give a shit what this looks like. This is just saying, what's f of 5? Plug a 5 in. Work it out. You're done.
So even if it's decimal, that's fine.
Yeah, even if it's decimals. Yeah. I like it. Because there you'll get 2.5, right? 2.5. I like it. Of course, decimals have to be, all right? Because this is going to pick up all kinds of ugly numbers in the middle there. Yeah. Maybe. So there are a few problems I like that do say, is this wider and narrower? Graph it. And then what's f of 3? Just to, maybe, I was trying to figure out why they did that, but now maybe it's just to remind you, oh yeah, this is still just a function. You can still just plug stuff in. We just happen to be able to do all this other shit. Vertex, how wide is it, whatever. But then they're saying, no, remember, it's just a function. You can plug stuff in. Okay. All right. Let me see. Anything else from homework right now? All right, let's do this. Let's talk about the last thing I've got to talk about. So let me see. Let me give you one right out of the book here. I like it. So let's say this function models the number of unique monthly Facebook visitors in millions X years after 2006. So X is the number of years after 2006. So what would X be for 2008? All right, good. So this one it says, cool. I like it. Okay. Oh, it's not doing what I wanted it to, but we'll do what I wanted to anyway. Would this have a max or a min?
Min.
Yes, why? Opens up. So if I said find the year when the number of Facebook visitors was at a minimum, right? That would be something you need to interpret. So find the year when it was a minimum number of visitors. So when you see the word minimum and you have this quadratic, you know that means find the vertex. I like it. So how do I find the vertex? Yeah. Negative b over twice a. see, anytime you have a function that models the real world, you're going to have fractions and decimals. Because most often the real world, your whole numbers are funny. Whatever the hell that comes out to be. Force. 3, I don't know what that's going to be. 1.1. What is it?
1.116.
I was almost there. 1.116. So how do you interpret that? What the hell? What letter did we just find? What variable? X. And this is the X part of the vertex. And for this, that vertex is the minimum, right? So we just found, but is that the year? Is it in the year, a little bit into the year 1? Was Facebook around then? Stupid rock. Come on. No, probably not. Sorry, that was just for me. So again, if X is 3, what year is that? 2009. So here it's going to be somewhere in the year 2007, 11. So somewhere in 2007 it was at a min for some reason. I don't know. Right? Do you guys see what I'm saying? No? Yes? So some of the problems that can give you an equation that has been constructed to model something. In this case, it models the number of visitors to Facebook. Given that equation, you can find a min or a max, depending on if it opens up or down. All right. Now, some problems want you to make your own equation. Of course, those are known as word problems. This is not a word problem. There are words in this problem, but this ain't a word problem because they made the formula for you. Not a hard problem. It's when you have to make your own formula. So there's one in the practice test. Let's look at that one. I don't have any practice tests left, I don't think. I've given all mine away. Is that true? Yes, that's true. What was the... It was the...
36 feet of fencing.
Number 9. Yeah, 36 feet of fencing for your dogs. Number... What was it? Number 9?
9.
9. So number 9 on the practice test. Now I'm going to create a rectangular play area, right, to keep them separated from my orcs and my other stuff. But I'm going to use one side of my house. I'm going to butt it up against my house, right? So it's going to look like, here's my house. And then I'm going to put the play area right there. So how many sides do I have to construct? That's crazy. Right. So another kind of a classic problem would be there's a river and you're going to use just 3 sides. And to me, I always love that because it's like the river could go down. What kind of things are you putting in here that are scared of water? But anyway, they like this problem where it's up against the river. This makes more sense. They're not going to tunnel into the house, I don't think. Hogan? They're going to tunnel in and go, ha ha. No, screw that. So tell me this. What does the 36 feet of fencing have to do with the picture I just drew? Perimeter. I like it. Because could it be like, it could have been skinny, it could have been like this instead. It could have been like this, right? Longer and less wide. Because if you make it longer, then I have less wood. So what I'm really trying to find is, or it could have been like this. Wow. Right, that's a little free. The dog's just running back and forth. Thanks for this. All right. Sorry. So that's probably not the way, but I really want it understood that that's why we bring variables in, because I don't know, when I draw a picture, it's not the right answer, it's just something I can label. So it could have been like this, it could have been really skinny. So what are you going to call this side?
X.
Sure. So what's this side? Good. What's this side?
Y.
If I call this X also, I'm saying it must be a square. Must it be a square? No, there's nothing that tells me it has to be a square. It could be a rectangle. But you'll get the wrong answer. That's the problem. It's a really fast problem if you only have one variable, but you get the wrong answer.
Oh, the largest variable.
Largest. So square is one possible thing. It could be a square, but I don't know. So I got to call this y. At the end, x and y could be equal. I don't know. Now, All right, let me go down this road real quick. If I was using all four sides, the answer is always a square. A square is the thing that will maximize the area for a given perimeter. Always. So why do it's not going to be a square now because I'm only using three sides. And to be honest, if I let myself use any shape that I wanted to, a circle would be the best. The circle has the biggest area for a given amount of material to construct it out of. Because have you guys ever seen silos where they put corn and peanuts and stuff? What shape are they in? Cylinders, circular basis, and like that, because they know it's going to fit the most shit in there, right? So they just know it. And then math came along and said, oh yeah, you're right. Right? Okay, sorry, I'll stop. So here, more than likely, it's not going to be a square, because I'm not using all four sides. But I don't know, maybe it will be. So help me out. This is related to the what of this? Perimeter. So what's the perimeter from the picture?
2x plus y.
Good, 2x plus y, and that of course has to be 36. All right, good. How many variables are in there? Good. So this is what they tell me. What do they ask me for? Largest area. So what's the area from the picture?
X times y.
X times y, I love it. Two variables over there, right? All right, I like it. Two variables is one too many. So does anybody have a suggestion on how I can use this to help me with that?
Substitution.
Yes, substitution. So if I solve this for what?
Y.
Please, dear God, don't solve it for x, because then you have fractions. So just subtract 2x, you get y equals 36 minus 2x. Stay with me now. I really want to show you. A lot of problems end up being parabolic in nature when they don't look like they will be in the first place. If I take this, I know y is this. So then how can I write the area? X times 36 minus 2x, because that's what y is. If I distribute the x, what do I get? I get 36x minus? What would that look like if I graphed it? You know. It would look like what? What's the highest power in there? Squared. So what would it look like if I graphed it? Be more specific.
Line go down.
Down parabola. I love it. Why is it down parabola? Because the coefficient of x squared is negative. Kick ass. All right. So this is part of what algebra is trying to do to you. We're trying to make you look at something in multiple ways. When I write this equation, it's an equation. I can plug shit in for x. I can do all that kind of stuff. But also I can think about this. What does it look like visually? Because very often if I think about both things, it will help me solve the problem. So I know this is a down parabola. It is going to have a max area. So the question makes sense. Thank God. If I got an up parabola, I probably did something wrong because they're looking for a maximum. I'm like, I can't help you, buddy. So I probably did something wrong then, right? But here it's good. So how do I find that? The dimensions of this. How do I find it? X. How do I find x for the vertex, right? I'm looking for the maximum of this. So I want to find the vertex. How do I find the vertex?
Negative b over 2.
Negative b over 2a. I love it. So whenever you see a problem that says find the minimum, find the maximum, for this class, you know we're talking about vertex. I like it. When you get to Math 176, maybe even calculus, if you're going there, you're going to do different types, because you're not going to just have a parabola. You're going to have these kind of functions. Wee-haw, woo. And there's no negative b over 2a easiness. There isn't. Too bad. There's other ways to do it. But for parabolas, I can always do this. Negative b over 2a. What's b? Careful.
B is 36.
B is 36. It's not just the second number that I see, or else I can make it anything I want to by turning things around. Right? So like, for example, what's the slope of this line? 3. Not 7, just because it's the first number I see. mx plus b, so m has to be in front. So where's a? A is in front of the x squared. Where's b? B is in front of the x. Doesn't matter just because they're in the wrong order. Be very careful about identifying a and b. B is 36. A is negative 2. So negative 36 divided by negative 4? 9. So I know that x has to be 9 feet. So how do I figure out what y has to be? Yeah, y is 36 minus twice 9. 36 minus 18?
Is what, 18?
18. So it's got to be 18 feet by 9 feet. That would be the biggest area for my dog to play in using the same amount of wood. And of course, I want to make it most efficient, right? Give my dog a lot of room to play in. That'd be nice. Then he'll guard my place when he works in that. Whatever else. Maybe. Now, I'll tell you this. I mean, the problem I'll probably give you would be more like this. This is going to be huge in pre-calculus. You're going to have a whole section about optimization, is what it's called. Make the biggest profit, make the largest area, make the smallest cost. Optimization, right? That's what it's going to be called. It's going to be all about this stuff. What I want you to realize now is, anytime I see them say find the max or min something, it's the vertex. That's what it is. Visually, that makes sense. Min, max, bam. I like it. And we have a shortcut for that. Bam! Shortcut. All right. So that was the last, and that's in actually section 11.1. There's the what you guys would call word problems. A lot of them aren't that because they give you the formula. Yeah, but a few of them you have to make your own formula. I like it. All right. So let me do this. I'm going to go ahead and give you guys the answer key for the practice test because there are a few at the end I need to do right now because I just ran out of room. You guys can say you had a whole bit in this room. I don't want to go there. How many of you guys, somebody this morning told me that they found some good YouTube videos for explaining different things. How many of you guys have actually even looked for other resources? Because you listen to me, you're like, oh, I can't listen to this guy anymore. He wants me to watch this video. You're like, shit. I understand that. After you've listened to somebody for a while, you're like, I need something else. I need, you know. So there's a ton of shit out there, but there's also a ton of really good stuff. So if you find somebody on YouTube or somewhere that explains it really well and that you start to understand it, let me know. I can put a link up on the website. I don't care if I'm the one that explains it to you. I just want you to understand it somewhere. I tell it to you the way I think about it, and maybe it doesn't jive with the way that makes sense to you, so find somebody that says it the way that you think about it. That's the way it works. Oh yeah, my math lab has videos, lecture stuff. I looked at them and they were okay. Yeah, they're alright. Yes?
I don't see answers for 6.
Did I skip 6? Oh yeah, okay. Alright, let's do 6. Let me borrow somebody's. Oh god, I skipped all of 6. Alright. Maybe I should have made one more page. Well, I failed that test. Shit. Alright. Well, here, how many of you guys have tried this out yet? How many guys have tried number 6 out specifically? Good! That's everybody. Try number 6 out. And then we'll do it together. Let my camera rest.